And the first guy I'm going to introduce and who's going to start this session off is Mr. Farid BAZIZI. Oh, he's obviously a unique guy because he's decided to have come from a different direction, and I'm looking over here. Farid is the inventor of the cube. I'll leave him to explain. Farid.
Thank you. Thank you, Peter. And good afternoon, everybody. So, just taking. So, we all have been confronted with such situation at least once in our life. A situation where we stand on one side and we want to get something from the other side of the shore. And as life is almost always complicated, there are obstacles in between. So now, after this short introduction, you might have two questions that pops up in your heads. The first one is, why didn't we have a short sleep after the lunch break for the digestion? And maybe that's a suggestion for Peter for the next session in 2021. So please use the apps to raise this topic. Maybe more important than knowing whether the session should be in June, in summer or in autumn. We need short sleep after the lunch break to recover. So, and the second question is about the connection between this picture and the topic, IoT, Industrial Internet of Things. So in fact, this one, I can fix it easily with a simple click. Here it is. You have on one side railway actors, railway players, whoever they are. They could be train owner, they could be infrastructure manager, they could be station manager. So they want to get some IoT data from the other side. And IoT data is anything from what we call the perception layer. So could be, we talk a lot about the positioning. So could be positioning of the train, could be also the wheel temperature of the train, whether the door is open or not on a station, could be anything that we might need to handle use cases. And I would like to use this picture to articulate my speech here. And before that, I would like to give you some insight about what CAPTCH is doing in this area. I'm not sure that everybody knows CAPTCH. It's well known in Austria, but not that much in the other places in Europe. So we provide the mission-critical communication solution for railway. That is so-called the GSMR technology that supports ETCS applications, so European Train Control Systems. And we have already equipped more than 80,000 kilometers of track, mostly in Europe. And what we have gained in terms of core competencies from this experience is, first, the capability to build a reliable network, and second, the understanding of the railway constraints, the true constraints that we have in the railway environment. And that's, for me, a fundamental point. So then let's get started with the first basic question. What is the use case here? So we know, we have seen from yesterday's presentation from Marco, he raised the question about, should we connect all the fridges? Wrong question. The right question is, what for? What are we going to do with those data? What is the use case? What is the problem we want to solve? So this is the first basic question, but the crucial question. There is another question, which is often, I would say, underestimated and even sometimes not considered, which is the obstacles. What are the obstacles to get this data, to access to this data, so that we can process it? How we transport those data from the sensor to the place where we're going to make the treatment, whether it's on the central point or whether it's on the edges. So this is a key point here. So in order to answer those questions, and I will start with the first one, the use case, because it's very specific to customer. So here, we at CAPTCH are promoting what we call co-creation and design thinking. So what is it about, in fact? I'm going quicker here. Co-creation and design thinking. So you have the traditional way of handling a development of solution of product, which is that you involve your customer at the early stage to get the understanding of the requirements, of the constraints, and so on, and then you do your full development cycle and you try to address those needs. Unfortunately, there are some statistics that says that more than 80%, 80, of product fail at the first time to address customer needs. It requires additional iterations. So this is why we are pushing for co-creation, meaning that to start working with our customer together to elaborate the use case, to get an understanding altogether about the needs and the constraints so that we can propose the right solution. So co-creation is one thing, and you have another aspect, which is design thinking. And design thinking is the complementary solution. It's more internal, how you design your product here. If I try to summarize it, make it short, it's like if you want to build a plane, you do it while flying, on the fly. It's a bit dangerous for aerospace, but maybe safer for railway. And those two things, both together, brings ability to have use case emerging. And that's crucial. And so my digital twin here wants to pass you two main learnings from the past co-creation and design thinking experience we have with our customer. The first one is for all the railway players. So dear railway players, please don't expect to have the full use case understanding before starting. This will never happen. So you have to start small. You have to start with some basics and to engage the ecosystem so that you can move forward and having the use case emerging. And most of the time, it's not landing at the place that you expected. That's the first learning. The second learning, and here it's more for solution provider like we, Capsch, are doing, fail fast so that you can succeed quicker. It's really important here. We are talking about what we call the minimal viable prototypes. Instead of waiting to have a minimum solution to come to the customer to start to experience it, you go with the very basic one and you provoke the feedback so that you can adjust the product and you can fail faster so that you arrive with the right product addressing the right use case. So these are the two learnings I wanted to share, at least for the methodology perspective. So this is about how to have use cases emerging. Now, let's talk about the second question. What are the obstacles? So here, the only thing I can do is to share the experience that we have, our vision about the obstacles which we have in between the two sides. So let me customize a bit the picture here. So on the right side, you have the perception layer, right? All the sensors, whatever it is, any data. And on the left side, you have the application layer, meaning that what we are going to make with the data. What are we going to make out of the data here? And so the obstacles is everything which is in between. So you have the ocean, you have the sharks, and so on. So what is it for railway? So our view is we have identified 5 major obstacles. The first one is connectivity. So it's not a secret that the wireless public coverage along the track is really poor. In France, it's around 40% of the track that are well covered by public network. And it's not going to change because of business logic here. So the connectivity is the first major challenge here. How to have connectivity along the track on a train that is moving inside the tunnel. This is the first thing. Another one is the nature of the data. Yeah, the nature of the data, meaning that mission criticality of the data, whether the data is important in the sense that it's not something that has to go fast and so on. It has to be secured. It has to be reliable. It has not to be exposed, sent over public network. If you are monitoring whatever data, such as wheel, temperature, and so on, you don't want to have this data accessible by any external party. So mission criticality is also important. Another one is the condition-based logic. So this one is more coming from our customer. When we presented some very nice curve about temperature of an equipment, whether it's the wheel or whatever, they say, I don't care. I don't care about those nice pictures. I just want to be waked up, alarmed, wherever I cross a certain threshold. That's it. And so that I can trigger the action. I can send the order. So they're really thinking about let's say, condition-based logic here. And so we need to process the data so that we only we trigger the action instead of sending all the data for processing on the central point. Another one is harmonized and open. So this sounds obvious, but harmonized in the sense that there are so many use cases that we will have to handle in the future. And we cannot end up with multiple solutions. And again, we are really good on providing the perception layer and on providing the application layer for the use case. But in between, no one cares for now. And we use whatever is there. And so there are multiple ways of sending the data, and then it ends up with different solutions, and we are losing the scalability. So it is key. And open, for sure, so that we enable our customer. We enable the ecosystem to develop on top of that. And to integrate also the very old systems that they have or the existing platform that they have. It has to be open. And the last one, it's environmental. So obvious here, we're talking about certification. If you want to have any equipment on board, you need to be certified EN 155. You need to have ruggedized equipment. You need sometimes battery backup and so on. So these are also the constraints that we are considering. And now I'm again handing over to my digital twins, who wants to say that, again, the industry is really focusing, the IoT industry is traditionally focusing on the two extremes, where here at CAPS with the Cube, we want to focus on this, let's say, communication layer on all these obstacles. So then, what is Cube? It's not really, it's not the asset, don't confuse. This is just a marketing asset here. And so let's go with the definition of the Cube. What is Cube then? Hold on. So the definition first, quickly. So Cube is a mission-critical, multi-mode and distributed IoT solution for railway. And the objective is to address multiple use cases. Let's go deeper now. And now the slide will start to be a bit more complex. I started with a nice picture because you're coming back from lunch, but now you have to be really attentive. So again, you have on the two sides, perception layer and application layer. And Cube, in fact, is a platform. Like Uber is a platform. Uber aims to bridge the drivers and the passenger. Cube aims to bridge the perception layer and the application layer. So this is the target here, and you have different sublayers here. Let's start with the first one, what we call the Edge Cube layer. Edge Cube means that these are the equipments that are installed in the different geographical area to collect the data, close to the sensor. If you want to monitor something into the train, you have to put an Edge Cube into the train. If you want to monitor something into the station, you put a cube in the station. So you have several edges instances, and there are some features there. For sure, you have the way it collects all the data from sensors through whatever technology of the shelf one, LoRa, Wi-Fi, wired, whatever is available here. It has the operability aspect with the zero-touch provisioning. It has a local database, and that's key also. It's not just a blind gateway that take the data and send it out. It stores the data locally, and this is one of the aspects of the mission criticality of the data. We're not allowing to lose any data here. And you have also the edge access point and the open API here, which is, I put it here in green, which enables, if you are at 100 meters around the box, to connect with your smart device through Wi-Fi and address and browse all the data that have been collected by this box. And then you have the core layer. And the core layer is just a software that supervises all the edge instances and have the super database, the master database. It has the sum of all those edges, the database from the edges. So you can also access with your smart device from the core cube. And there, the only difference is that you see all the data from all edges. And what is important here is the communication layer here in gray. So the cube aims to reuse the available and existing networks, whatever it is. If you have 4G, it has 4G connectivity. If you have 2G, it goes with 2G. If there is Wi-Fi, it goes with Wi-Fi. Even it is capable to go over GSMR technology, which is a perfect coverage wherever it is installed in the rail environment. So and this is the last feature here, the aggregation and hybridization here in orange, which allows to make the best of all the available connectivity means. So let's go now into the, let's say, the use case. And I will just not go with my digital twins again, it's speaking too much. So we are considering freight use cases. So there are two use cases we can consider here. Provide train connectivity for the driver, for the staff operation who are managing the wagons and so on, to get connectivity, to access any apps, to store any data, to collect any information. And also train supervision, so to have sensors into the train and to collect those data. So you have a loco here and some wagons. So you put a cube inside, and then on the journey, on the path here, you have some, I just illustrated the connectivity here. So you can see I've taken an example with 2 public network coverage, right? And GSMR. And obviously, GSMR has a perfect coverage because it is fitting, it is really on purpose along the track. So then the cube is taking the best of it, and even sometimes the sum of it, and provides this connectivity to the driver thanks to the Wi-Fi access point directly with this smart device. So this is the one aspect. Another aspect is that you can put sensors into the wagons connected through whatever technology, and it connects to the cube, it processes the data, it stores it, it makes it available for the train, and it sends it over also for central point. Let's go a step further on the use case here. This is a recent use case. We work with one of our freight customers. So they are transporting petrol. And during the journey, it happens that the petrol is stolen. So they want to monitor all the wagons here, and they start thinking, saying, OK, we need smart valves, right? But unfortunately, there are so many kind of wagons here that this is not affordable. So what we then suggested here is to use a padlock. So this is a padlock, right? It's a smart sensor, so you can lock any valves here. It's connected through LoRa, and so you can monitor whether it is locked, unlocked. You can remotely control it, so lock it or unlock it remotely. And you can also, whenever it is cut or broken, you have an alarm also. So this is the device that we put on the wagons. So, and concretely here, we had this sensors installed into each wagon. So there were 2 valves, in fact, on each wagon. And we put the cube on the loco. And you can see here, with the blue part, we were using LoRa technology to collect all the data and to control the sensor also. It's a two-way communication. So we can, the driver start his journey and say, OK, now I'm locking all the padlocks. And wherever it is open, there is an alarm. Or I unlock them, or I disable the alarm. So anyone who is touching it, there will be no alarm. So there are some very basic features like that we provided through an interface. The train driver can directly get this interface accessible through the Wi-Fi access point, or even centrally through the wireless network from the operation center. So this is a use case. And again, my digital twin here will complain because there was one unexpected challenge, which was the connectivity with the length of the train. So it can be up to 1 kilometer length, and it's not easy to have the last wagon reachable from the loco through LoRa technology. So we had to tweak it a bit, but finally we made it. And so it is under trial experimentation with the customer here. And again, co-creation here. So that is a use case, a concrete use case that we can work. And now I have 50 seconds to conclude. And I will hand over this to my digital twin, who will tell you what you should remember from this presentation. The first thing is about co-creation and design thinking. I would say 3 keywords. Start small. Don't wait for the full use case. Fail fast. Succeed quicker. There are different approaches now to address the use cases and the various needs. Second is the IoT railway challenges. There are IoT railway challenges, although it's not something that I heard from all the presentation here. They are, let's say, the reality is that it is not easy to collect the data here. So, and with the Cube, we want to address and we want to put all our knowledge that we gather from let's say, the telecommunication, GSMR technology, and so on, into this field. Thank you.
Farid, to you and your digital twins, thank you very much.
He will be the one who will answer the question.
Well, if there's any questions for his digital twin, just let's have those as well. Well, that was fantastic. I like the way you're approaching it, starting small and not trying to solve the problem right at the beginning. And like you, I was a project manager and director many years ago. And I read an article that said over 90% of major projects always fail, and it's usually down to that planning at the beginning and getting it right. And so I have a lot of sympathy with that. And I know CAPS reasonably well, by the way. I was there in the 90s. Right, questions for Farid and the digital twin. 8 votes there. What is the SIL level of data transmission?
I would say the short answer, it depends on the use case. If we need, really, we have critical data, then we will have to secure it. We started to work this concept with our railway customer who has their own GSMR network, right? And today they are paying huge costs to public network to get IoT connectivity, and they have poor results. So they asked us, and that's why I'm talking about co-creation, because more or less this concept has been co-created with our customer. They even asked us, okay, can we reuse our GSMR network? We made so huge investment into it, and it's a so perfect network, although it's not a high bandwidth throughput. It's enough to, let's say, support the condition-based data. So I would say that the data transmission depends. We will rely on the available networks. If we have a GSMR network, then it's fully reliable and certified. And about the boxes, the box I have presented here, the Smart IoT Gateway, the H-Cube, is railway certified, and so it's able to run on board.
There are 2 questions there that are sort of the same. So the second one down, how did you convince, engage your customers? And the other one is the Cube solution aims to address use cases. How did you manage the customer customization? And I guess that's the collaborative approach up front.
Yeah, absolutely, Peter. So it depends. I mean, it's all about relationship with our customers, and trying to understand really what are their needs. Most of the time, they don't know about the use case. They started to think about that, and they even don't know where they're going to land. So what we are offering here is say, okay, let's have some round of discussion, even if it's once a quarter, about what are the different needs. And we are also trying to collect the use case knowledge, what we call the use case knowledge, so that we can also share it with the different operators. And our customers are really in favor of that, to share their own use case and to get understanding from use case from the other, let's say, railway operator. And we are bridging these two things. So it's a win-win model here. So it's not that much effort to convince them. And regarding the various use case, it is true that the scalability is critical. And if you provide a solution, then it has to work to fit with any kind of use case. Otherwise, it's not even sustainable. So if you remember the picture with the two extreme sides, the perception and the application layer, these are the area where we put customization. On the perception layer, obviously, it is about the kind of sensor, the padlock here, or any kind of other sensor. It depends on the use case. And on the application layer, it's the way we visualize the data. But the key features, the key challenges I've talked about, connectivity, condition-based, all this is generic and is scalable and is applicable for any use case that we have in a true railway environment.
Wow. We'll take one last question, and I'm just interested to see what the answer is here, because it seems obvious, but it's the one. What is the result of using the padlocks? You said the petrol was stolen?
Yeah.
And you put the padlocks, I mean, you genuinely, they've all got one, you can lock them, unlock them? And
yes, so there are several ways, let's say, of using the padlocks with our customer. First of all, you have the operational team who are, it's on the east side of the Europe, so somehow the temperature goes below 0 degrees, so they cannot go with their smartphone or with tablets to activate it because there are some near-field communication technology here where you use smartphone, you can unlock it or not. So we need to enable them to unlock them and lock them locally, remotely. And in fact, we understood while working with our customer that the use case is not really that there are some petrol that is really stolen, because I was also wondering who is stealing this kind of petrol along the track. But the business case is they are paying a company to make the surveillance and the tracking of all those wagons. And they want to save costs with those padlocks. That's it. So sometimes it's really basic needs here.
And I'm guessing the padlock is an instant deterrent. The guy sees a lock and...
Yes,
okay.
Yes.
Perfect. Well, once again, thank you very much to Farid. Please show your appreciation.
Thank you.
Well done.
Thank you,
Cheers, Farid.
Thanks.